in my previous experience with teaching science, it was a lot of, when it came into classroom experiments and these sort of things, I would supply a lot of the tools and a lot of the equipment for the science experiments to be done. Mm-hmm. And so it was a lot of me supplying, and the students then like, oh, okay, this is what we're working with today. While the makerspace, I found that it was more student generated. Mm-hmm. They brought in the materials, they brought in the things that they felt best fit the task at hand, and so it was them being more creative with this sense. And when it came to my students, they fell in love with it. They fell in love. They're brainstorming and problem solving with a group about what materials they wanted to bring in, and it really brought ownership of the entire lesson onto the students. And you could see this spark in them and this energy about what are we going to do? What materials are we going to bring in to best fit this experiment or the questions in which I pose to them? I had my students and partners in groups when they were working with the makerspace and our certain lessons. Now, granted, they would probably have the same sort of cooperation, building, teamwork within other experiments, but I felt this really brought the partners really close together because of how much weight was on the project, because they were designing and creating and building. And so how much pressure really was for them to work well together really brought out the teamwork and the cooperation, because it really boiled down to how well they worked together. If they did not work together, they weren't going to be successful. And it was really clear within my makerspace lessons that the students who had the cooperation skills, had the teamwork skills already in them and built over time, for most of them, I'm sure, they really succeeded. I mean, they did an amazing job. And the students who had a hard time communicating, had a hard time working together with a partner, you could see their struggles, you could see their frustrations when materials were brought in, when they hit a snag in their construction of their car, which what we did. They kind of shut down. They didn't know what to do. They didn't know where to go, and they didn't know how to rely on their partner at all to overcome their failure. And so you could really see the teamwork and the cooperation skills really being an integral part of their science experiment. Yeah, they're not used to failure at all. They see failure as something that is the worst thing ever. They see failure as something that can never be overcome. They don't know that we all fail all the time, and that failure is something we all have to deal with. And a lot of the students, they shut down. They come across a snag, they come across a problem, they failed at something, and they shut down. A lot of the students don't realize, because of their failure, there's a way to which then you can look at the problem, analyze the problem, and then look at a way to solve the problem. And then get into problem solving skills and all these other skills that are applied upon to what failure brings. But it is definitely interesting to see when they come across failure and how they shut down because they don't know what to do. And makerspace really allows the students, because they experience failure a lot in makerspace. And from the first week that we introduced this project and they started constructing, they all failed across the board. But then week number 2, they took what didn't work the first time, and they did something, whatever each individual group, they did something different. And by the end of the second week, they had some sort of car that was moving, and you could see this light in them, like, oh my gosh, we did it. It was just like, from 1 week of they just shut down to a week of energy and enthusiasm. It was amazing to see. And I don't think with any other style of science experiments that I've been a part of, they don't experience that much failure that makerspace allows them to experience. And it was amazing to see the growth in who they are as students when they come across a problem. Because previously they would, like I've said before, they would shut down, and they didn't shut down.
Yeah.
You know, it was amazing to see. I worked with the FOSS kids, and our curriculum was electricity and magnetism. And I've taught fourth grade for 4 years now, excuse me. And so I'm pretty comfortable and aware of what the learning objectives are for the overall units when it comes to magnetism and electricity. So what I did was I took those learning objectives and I put them visible for the students to see throughout all of our science classrooms and throughout all of our science experiments. And I addressed those learning objectives daily. They reflected on those learning objectives daily. I started out the makerspace with actually doing FOSS kit lessons. I introduced the learning objectives, a specific one, like for example, a circuit is a pathway that allows electricity to flow. So we took the actual FOSS kit materials, we built circuits, we allowed ourselves to see what happens when you connect an energy source to something that is run by energy, and you can see the circuit being built. So they're becoming aware of what a circuit is. So we did 3 weeks of science experiments out of the FOSS kit to build their knowledge of the learning objectives. From that moment after I think we did 3 weeks of FOSS kit lessons, just what we normally would have done in previous years. A little bit more condensed. We didn't do a lot of the experiments because we needed time to then implement the makerspace. So the 4th week, I posed the question. I was like, can you design, create, and test a car that is powered by electricity? And so I posed this question to the students. And from that moment, we just kind of talked about, well, first of all, I had to do a little teaching of what a car is, and the chassis, axles, wheels, kind of the really basic teaching moments of what a car is. So I had to talk about that, which I did. I did that the same day I posed the question. Then the students were then to bring in materials that they think they could use to build a car that would meet or answer, the question that I posed to them. And so the first week, they just brought in materials, and like I said before, that first week they had all these materials. Like, where do we go from here? And a lot of students they didn't know where to start, they didn't know where to begin. They failed that first week, and it was a struggle for them. Then at the end of every week, I asked, what was successful today? What was not successful? And then what could you do next week to improve upon this week? And they did reflection questions within their science journal. And I think that really brought it in. They kind of really wrapped their brain around, okay, some things were successful, some things were, and there has to be a next step. And so they did some reflection, and then they talked with their partners about their own personal experiences of this unit. Then the following week, we reviewed the learning objectives, and then the students took what their next steps that they wrote down in their science journal and started from there, and then went into their car, and then they were able to go from nothing to something, and then all of a sudden the following week that something went into a little bit better, and a little bit better, and a little bit better, and then finally at the end of a 4-week session of just construction, failure, the students had a working car that was powered by electricity, that had a pulley system, a drive line, which connected to a pulley on their axle, which turned the axle, which propelled their car. Wow. I mean, it was something to see. And at the very end of it, it was just a very quick little assessment. I assessed them as they were going through. I would go through and look at their science journals, and I would ask little probing questions. What learning objectives from our electricity unit did you apply in today's lesson? Like a lot of them were like, we didn't get far today. I'm like, well, that happens. That's okay. You know, I'll talk next week. I'll talk next week about you when you're a little bit farther in, and we can talk about what learning objectives you applied. Right. And the other students were like, well, we were actually able to make our circuit. We were able to do that. We did that first. And so tell me about your circuit. Talk about it. And so I was able to, get some assessment going on, just kind of asking guiding questions as I monitored the room. And at the very end of it, I had the students draw me a diagram, a design of their car. Talk about what learning objectives they applied within their makerspace to make their car run. And from that, I was able to see which learning objectives students used, and it worked out wonderful. At the beginning, I was a little apprehensive, and only because I've never done makerspace before, and it was kind of new to me to see all this construction going on and all these individual all these individual groups going on. And I was really, number one, concerned about safety of the students, with using scissors walking around, getting all the supplies needed. I felt that, I had to be on edge just to kind of monitor things that were going on. After a while, students demonstrated that was a worry that I didn't need to have, because they did an amazing job understanding safety of the school, of the makerspace. As I observed it, after a while of just seeing, it was chaos, it was a mess, but it was a beautiful mess, because it was the students being hands-on, designing and creating a project that's all their own. Granted, I posed the question, but how they answered the question was their own. And it was amazing to see a pile of supplies here, a pile of supplies there, students just hands-on, hands in the materials, talking about the materials, communicating about what they were going to use, how were they going to do it, why they were going to do it. And at the end of it, I was like, room may be messy, but it's definitely a beautiful mess. Number one, when it really comes boiling down to this makerspace, understand the learning objectives that you want the outcome of your students to have. That's it. That's number one. Okay. I personally, I had a really solid background of my FOSS-KIT, of my science curriculum, so I knew what my learning objectives were. If some teachers, they're brand new to their particular unit, their curriculum, just dive in, understand where your learning objectives are. Make those learning objectives part of your daily conversation with the students. It'll be amazing as you do this. The students will then use those learning objectives in their own speak. From there, relax. Understand that it's going to be tough at times. The students will struggle. They will get frustrated. They will fail. Now, obviously, you want to then go and help them. You want to be a part of it. You want to kind of guide them into where you want them to go. But the key is to not do that.
Yeah.
The key is to not do that. The key is to allow the students to get there. And you'll be surprised they'll get there. And you know what? They end up conversing with themselves. They go to other groups. Hey, how'd you guys do that? How'd you guys, we use this applies. I'm like, I had no problem with them doing that. No problem at all, because they are finding the answer to their problem on their own. And whether they went to another table group, another partner group, and kind of asked them, kind of observed what they were doing, they found the answer to the problem that they were having their own. And without coming to a teacher, without going to an adult, they figured out the answer on their own. And that was amazing to see as well, and I should have mentioned that previously, is that they found their solutions to their problems without going and seeking an adult. They found their resource that they needed. And that's going to be amazing for you to see, and amazing for you to watch as a teacher who's implementing the makerspace, is the camaraderie, the teamwork, because everybody's in it together. Everybody wants everybody else to succeed as well. It's very beautiful to watch. So for teachers who are interested, are thinking about it, I definitely highly recommend it. Number one, just know your learning objectives. Know where you want your students to go. That's priority number one. And give them the avenues, give them the means to design and create and just build, and just let them do what kids do naturally, is by being creative.